trim off that first 10 seconds. Let me tap and see if full screen.
Hey folks, we're going to get into some HSRP, some default gateway redundancy. All right. So we are in our lab here. I'll flip the camera around. Yeah, I'll wait for a few more to join before we get going. We're going to be doing some default gateway redundancy, configuring Cisco routers. Are you the moderator?
Yes.
Huh? Are you the moderator? Who did the heart? All right, we're gonna be configuring Cisco routers for redundancy here pretty soon. I'll get going. All right, so here's the topology we're working with, folks. We have a laptop connected to a switch that's connected to a router that's connected to another switch that we're simulating is the internet, and we're pretending it's like a Google DNS 8.8.8.8. Here's the laptop and the topology, and here's the switch 1 that the laptop is connected to right here, and here's router number 1. Okay, and here's switch number 2 that's in this picture here. Okay, so the problem that is being solved is every network has a default gateway. This is the default gateway. I'm going to write down some IP addresses. Josh, you can help me by holding that. Can you see the screen here?
Yeah. On
my screen, I am 192.168.20.10. That is this laptop. Default gateway 192.168.20.1. So this subnet in here, it'd be nice if I had a colored pen, represents the 192.168.20.0/24 subnet. This router is .1. This laptop is .10, right?
Yeah.
Okay. So if we had a lot of other computers hanging off of here, hundreds of computers, let's just say there's 100 computers, you lose your default gateway. If this takes a power hit, if this has a problem, all these computers are isolated from the internet. They no longer have network connectivity to any other area of the corporate network that's back here or the internet. And so that's why Cisco and the industry came up with what is known as first hop redundancy protocols, FHRP, first hop redundancy protocols. Now, FHRP is not a protocol. It's a description of a family of protocols. 1, 2, 3 that I know of. My son reminded me of another one that I had forgotten about. HSRP, Hot Standby Routing Protocol, Gateway Load Balancing Protocol, GLBP, Virtual Router Redundancy Protocol, VRRP, and my son reminded me about IRDP, ICMP router discovery protocol.
ICP router, I
Okay,
believe. Yeah.
IRDP had been so long since I had even heard about that. So HSRP is Cisco proprietary, PROP. I'll just put proprietary. GLBP is Cisco proprietary. VRRP is an Internet Engineering Task Force standard. Okay, so if you have a multi-vendor environment where you're dealing with multiple vendors of routers, you're probably going to be wanting to use an Internet Engineering Task Force standard for a first hop redundancy mechanism. If you're sold out on Cisco and you've got tons of Cisco, then you can use one of these. And I don't even know if anybody uses IRDP anymore. Are we getting any questions or comments?
Let's see. A couple people asking where you got that many switches. So we bought the switches and routers on Craigslist. We got them all for about $200, and each of them are they're all Cisco switches, and then we got some IP phones. But
a whole stack for $200.
Yeah, you can get some good equipment over on Craigslist. It just takes some searching around, and we had to drive a little out of town for this batch of equipment, but it was worth the drive.
It came out to about $7 a router. We got a really good deal.
Yeah,
it's crazy good. And we understand there's some wonderful virtual environments out there like EVNG, Cisco CML, Cisco Packet Tracer, GNS3. I mean, there's a lot to be said for not stacking up a bunch of gear in your room, using power for it. It's ancient, it's old. You can't take it with you. I mean, you could set up remote access to it, maybe, but anyway, the virtual environments are wonderful. But for my son, it's learning his CCNA to get your hands on some gear and just solidify some concepts. In the early stages of your learning, there's a lot to be said for that. If you can get it for cheap, why not?
Yeah.
Okay, so let's get back to this. Any more comments? I have a 2811. I have a 3560s. That's exactly what we got. We got a bunch of 3560s, 2811, 2821, 2851. That must be heaven. Yeah, bunch of gear. Bunch of network nerds playing with network gear.
$200 is not bad. I think I use those in my Cisco class.
Local network routing layer 2 protocols. All right. What does the switch do? It forwards Ethernet frames at layer 2. That's pretty much what a switch does. If you want to ask a more specific question, go ahead and fire away. Where do you learn this? You can learn it right here. Where did we learn it? I mean, I've been doing this for 25 years. My gosh, there's a ton of information on the internet. TikToks, look at ours, look at my YouTube channel, look at everybody else's. There's a ton of information out there that people are sharing on how to get started in entry-level Cisco stuff or entry-level Juniper, and so lot of free material out there. Okay, look into CCNA for Cisco, JNCIA Junos for Juniper. Those are good entry-level certifications to look at the blueprint, look at all the exam topics, and just start picking away at them one by one and climbing the learning curve. And before you know it, you'll probably be certified. Okay,
There's a lot of stuff on YouTube too.
Python and network automation. I'm sorry, I just dropped down to the most recent comment there. I don't know a lot about Python and network automation. I've been dabbling with it a little bit. I teach it in some of my courses for a training company that I work for. Just some of the RESTconf and NetConf and Yang and some of the configuration protocols. But I just barely touch on them because I don't go very deep because I don't really know a lot about network automation at this point. I'm kind of in the early stages of learning about it myself. It's really new in the industry, and it's some good stuff to go after these days.
Python is probably something I'll start learning once I get my CCNA. So you guys might see some content on that in the future.
Yeah, if you're an up and coming, network administrator or engineer, you're going to be probably faced with learning about automation in the new exam topics that they're requiring that we know these days. And Ansible comes up. Yeah, Ansible with Puppet, Chef, Ansible, all those fall into a certain family of automation or configure. I think they help with what is it? Keeping configurations consistent across devices. Or I think that was big in the server arena for so long, and now it's coming into the network world. Some of y'all are going to know more about that than I do. What jobs are out there for getting certified? Do they pay well? Yeah, it's you get in as a technician, and the more you learn and the more experienced you get, you move up to analyst, then you move up to engineer level 1, engineer level 2, a senior engineer, and so it's a good field to be in, because the upward mobility and the pay increases that you can get that go with the increases in your position are pretty significant along the way. Excited to get into the field. Good. Stay passionate about it. It's a lot of fun stuff. There's a lot of technology is always changing. So for somebody that loves learning, you're in the right field. Somebody's got a 2600 router. Yeah,
Nice.
those are pretty old. I remember the old 2500s that I used to play with too. Firewall, which you consider the best. Oh man. Juniper's SRXs are pretty sweet. They've got a lot of they've got a huge family of small ones all the way up to really big ones. And I used to mess with I've got some ASAs in the network that I take care of, and some Cisco Firepowers. Those are just the ones there's Palo Altos, and there's all kinds of different firewalls. I'm not big on comparing firewalls, so I can't really tell you which ones are the best or not. So let's get into this, okay? Let's get back into this, folks, and we'll look at the questions and comments in a moment. Where's we need to flip the camera around. So these are the first hop redundancy protocols, okay? Mm-hmm. And it's in first hop is all about, if you do a trace route from the laptop, when you do a trace route, each hop on a trace route is a literal layer 3 hop. So, you're not going to see much on this trace route here. You'll see just a couple hops because this is a small lab. But the first hop is your default gateway. That first, if this was a list, we could do it on his computer and trace route out to the internet. But let's just talk about it here. If this was 10 hops listed here, the first one is always your default gateway, okay? And so It's all about creating redundancy in the first hop. The deal is that there's not a dynamic routing protocol that runs between the router and the PC. There's not a dynamic routing protocol. If there was a dynamic routing protocol, we could stick another router here. I'm going to go ahead and draw it. I'm going to say this is router 2, and I'm sorry, I'm writing sideways. If this was router 2 and they were running a dynamic routing protocol, and we were also likewise running a dynamic routing protocol here and here, well, we could advertise routes such that the laptop is learning routes, and if this router goes down, well, he learns these routes, and let's just say we have another connection here, and he learns that he can now get out to the internet over here. And we don't really need a first hop redundancy protocol family, because we'll just run OSPF or RIP. But that's just not what you find in the industry. I will say that I have ran, I think it's RIP, Routing Information Protocol, a really old routing protocol. I'm pretty sure I've ran one in a Windows computer before. You can do it. But come on, it's just not done. You don't run networks. You don't set up computers to run routing protocols. So that's the deal. Since you don't have a dynamic routing protocol running in the LAN, in the local area network, that's the purpose of your first hop redundancy protocols, because you need redundancy in the first hop. So what's going on is what you do is you connect a second router to the switch. All right, so let's do that. Let's connect this second router, router 2, and what do we got? We're on F00, so let's stay consistent. We got F00 here, and we're going to connect it. We're on FO24 on switch 1, so let's go to FO23. Okay. So we're connected to FO23 now. Okay, it lights up. Do you have another cable, Josh? I think you have a short one that went from your. Because we're gonna need it.
Is that green one?
Or this gray one? Which one is it? Green or gray? This is
the gray one goes to my PC. You can grab the green one though. Well, the green one goes to the wall actually. So pull the gray one.
Oh.
Yeah.
Oh, so it's the gray one. Where does it go? Oh, then you're gonna have to
disconnect it.
Yeah, here, let's just do this. I'll borrow this cable because we're gonna need it in a second. Sorry, folks. We're just setting this up as we go and explaining it as we go. Okay, we'll need this one later. So, you'll buy a router. Your company will see fit to create redundancy. They'll purchase a router. We're on F00 here. We're on FO23 here. 23 here. And so what you'll do is you'll run HSRP. Let's just use that on FOO here and FOO here, and HSRP will pass protocol packets back and forth over the LAN. It needs to be in the same VLAN. Okay, you can run HSRP on multiple VLANs, but if you learn it in one VLAN, then you can understand it in multiple VLANs. Just learn it in one VLAN first. So we turn on HSRP here, and then they start advertising to each other who's going to be the active router. Okay, so let's do that. Okay. Go in to router 1. Now, you know what? First of all, let's show that we can ping. I think I already did that. We can ping Google DNS. That's our emulated Google DNS right here. All right, so we can ping there. We're good. And you
it's
need
on the
to
switch.
Oh, you're on the switch?
Console.
Okay. So we are in router 1 now. If I can get in there. There we go. Okay, now you're in router 1.
So we're gonna set this one up as the
Well, you have to
with HSRP.
Yeah, and here's some of the configuration commands. HSRP has 2 different versions. The most recent is version 2, and so let's just. This is the basic HSRP command. Standby 1 says it's standby group 1, and we're going to give it an IP address.
So we'll go configure terminal.
Now let's show the configuration that's on that interface first.
Okay.
We're configuring F00.
So I'll go do show interface F00.
Yeah. No, show run.
Okay.
No, do show run.
Yeah, you're right.
No, do show run interface. Or else we're looking at everything.
Zero.
Yeah. So you can no longer, whenever you're setting up first hop redundancy protocol, HSRP, you no longer have the .1 assigned to the actual router's interface. You have to get rid of that. You have to run 2 unique IP addresses in this VLAN. So you would set up this one as .2 and this one as .3.
Okay.
Okay. So go ahead and you'll overwrite that configuration with a .2.
Okay.
You just copy and paste it. Oh, if you go too far, it'll hit enter. Yeah. You can't use your mouse in CLI.
Oh, you're right.
Yeah, just make it .2.
Oops. Dot
Okay,
2.
yeah.
Okay.
Now, by doing that,
Oh,
you're not in the interface yet.
Oh, you're right. And then go IP address. Change that to .2.
Right.
IP address conflicts with gateway IP address static routing table.
Huh.
So we have some type of routing.
Well, type do show IP route. Do show run pipe include IP route. Yeah, I think we have some old. Yeah, get rid of that route. Just type no and then copy and paste that. This is remnants of an old lab that we had in here from last week. Okay, so go back in the interface and do it again. There you go.
Right here.
Okay, by doing that, you probably broke my ability to ping. That's interesting. It's still duplicate IP. Oh, okay, so yeah, we have to go to the other router and we have to default it because this is left over. I think this is left over from a previous lab. So let's go back over here and go into that router and get rid of the configuration on the interfaces. Show run interface F00 and show run interface F01.
Interface.
Yeah, you got to get rid of that. It's a duplicate IP.
20.2.
Yeah.
And then
Just go in there and say no IP. Oh, yep. I was waiting for that. My connectivity is broken on my laptop now because we're reconfiguring the way that our default gateway is. So it no longer has .1 as a default gateway until we get HSRP up and running. Okay, so we're cleaning up router 2.
And we have F01 too.
Well, what's on F01? Look at it.
30.1.
Yeah, get rid of the helper and
Oh, right. Oh, yeah, because we set this one up as a DHCP relay.
Yeah, that was an old lab we did.
One video.
We did a lab earlier with DHCP and we were using IP helper and stuff. So
Get rid of the IP address also.
well, just override it with the one that's going to make us connect to the internet. Remember we use 8881 over here. Let's just use 8882 over here, so that we can simulate internet connectivity.
So 8882, like this.
Yeah, do that.
Okay.
Okay, yeah, somebody's saying, why don't you do the route with 0000? Okay, a default route. Yeah, that would be how you would create the routing in the router 1 or router 2 to connect up to the internet. But like somebody else said, we're creating redundancy in the LAN, and so you wouldn't use default routes for creating redundancy in the LAN. That's what HSRP is for. Do we do RAS VPN? No, we don't have remote access and VPN in the lab yet. So we haven't done that yet. Okay, so let's go back to router. You can Control Z WR, save the config. Yep. Let me switch us back over to the other router. Okay, I got to keep moving this console cable back and forth. All right. Now, the show run interface F00, we're still focusing on configuring HSRP. So right now we have 192.168.20.2. We need to get the basic HSRP standby command in there. Okay. So go on that interface and put standby 1 IP and the.
Wouldn't have to go standby version 2.
Now let's just go with as little commands as possible and let's see how it works.
Okay, standby 1 IP.
and you're giving it the virtual. No, you know what? Go back where it just says IP and put a question mark. Oh, you're not in the interface yet.
And that would be F00, right?
That's right.
It's going to be where the default gateway is on the line.
Yeah, you have to. We're configuring. Sorry, the diagram got a little sloppy here, but here's the laptop, here's the switch, here's the two routers, and we're configuring HSRP on F00 of both of these routers. So here we are in the first one, F00, and do the standby command. This is the basic HSRP command. There's a lot of different things that you can configure as well. Go back and do a question mark, and let's see what it says.
Okay, right here.
Yeah, there you go.
Virtual
so it
IP
tells you
address.
this is the virtual IP address. So what's going to happen is, if you hold this, what's going to happen is between these two routers, an election takes place of who's going to be the active and who's going to be the standby router. And whoever's the active router, sometimes you'll see a drawing where they have this like little cloud with another router in the middle, and it'll say, this is the phantom router or the virtual router. When in reality, it's actually residing in the one that's active. So you could draw a little virtual router inside of R1. Whoever's the active router, I'd like to just put the letter A and the letter S, active or standby. I think that's what it's called, standby.
Yeah,
we'll
it
find
is.
out. I'm kind of remembering a lot of the terminology as we go.
Someone says, why didn't you guys make a sketch of the network and packet tracer? We could have. We just wanted to get some hands-on experience with some of the equipment here.
Yeah. I mean, we've got all this. Can I not zoom out or zoom in? Yeah, we've got all this gear, so we're just using it. We could use Packet Tracer, but we're just messing around with some real gear for now. Okay, yeah, so this is the virtual IP address. So it is the virtual .1.
The one, right?
Well, it's 192.168.20.1.
You're right.
So this is the physical IP address of the interface. It can no longer be .1. You have to change it to .2. Each router has to have .2 or .3, some other actual IP in that subnet, but not .1, not whatever you want to be the virtual IP address. That's what's configured here. So go ahead and put that in.
Okay.
And when you put that in, let's see if... Now, you know what? Quickly go in here, Control Z, show standby. Okay.
Active router is unknown.
Yeah, let's see. Hit the up arrow. Oh, there it is. Okay, just watch it. See, it said active router is unknown. And look, now my pings are coming back. So the active router came alive. The HSRP virtual router came alive and it went from standby to active. Okay, you see HSRP state change. If you hit the up arrow, you'll see that active is no longer unknown. Hit the up arrow. Let's look at that command again. There you go. Active router is local. Standby router is unknown. So we have a router running HSRP, router 1. We have a virtual router running inside it as an HSRP virtual active router. But we haven't configured router 2 yet as our redundant standby router. Okay, because it says standby router is unknown. If you hit the up arrow and type brief, BR, enter. There you go. That's kind of nice, right? Mm-hmm. So it's just here, I'll clear the screen. So that's just a nice, concise way of looking at it. Tells you what interface it is. It tells you the group number, the priority. Active means that we are active. This router is active, the local router. Standby is unknown, and this is the virtual IP. All right. So
let's explain this real quick. The priority, because I just learned what that is.
Well, the priority, the default priority, obviously is 100. We haven't done anything to change that, and so this is what dictates who is going to be the active router.
Through the election process, it picks the highest priority, right?
That's right. The highest number wins. But in a case of a what do you call it? The same. In the case of a tie, if they're both...
Both of them have 100, it would pick... What would it resort to? Is it the IP address? The
yes,
highest IP address?
it resorts to the physical IP address, and I think it's the highest one wins.
Okay.
Okay?
And then the range of that is it
The range? What
there's
do
a
you mean?
there's a priority range that you typically have. So
You mean this priority?
You can manually set that priority to be higher if you want this router to stay as the active. Right?
Absolutely.
Okay.
Yeah, you can anchor it and hard code it. Go in there and see what it is.
Okay.
Config T, interface F00. Standby. Space question mark. By the way, this will tell you how many groups you can have. Group number is 0 to 255. If you change it to version 2, I think this goes up to the number of VLANs, 4096 or 4094, whatever.
So
priority. So type prio tab, a question mark. There you go.
0 to 255. Okay.
Yeah, and so when you change to version, now get rid of priority. Control W. Type version, question mark. Yeah, when you go to version 2, some of these things may change. Okay. Let's see what questions we have.
And that's what it had me do up here, actually.
I know. Some of these questions. You guys rock. Thank you.
Appreciate it.
Do you have or ever use Wireshark? Heck yeah. I'd like to do a TikTok or a video tutorial on Wireshark. Just, I swear, Wireshark opened my eyes to the world of networking. It really makes it where you can. Oh, I'm sorry. I thought I was zooming in on the cable here. Let me flip the camera. It really makes it where you can know what's going across this cable. There's so much in networking that's occurring, and you want to know what's going through this cable and what's going in and out of these ports. Well, Wireshark was a complete eye-opener to me when I first started learning about networking in the mid-90s, when I could start actually seeing what's happening at the layers of what we call as the OSI reference model or the TCP/IP model. I could start actually seeing the packetization process of Ethernet frames and IP packets and UDP or TCP layer 4, and above that the application layer. And so, I can't say enough about how Wireshark, how you can really gain an appreciation for what is actually going on in the network by being able to sniff packets using Wireshark. Look at my bio, my link to my YouTube channel. I actually have a video on Wireshark and packet sniffing and stuff. I do this for work, have my CCNA in the past. Love watching you guys through it. Awesome. Glad cool. You are enjoying it. That's cool, man. I do all of this at school. Cisco routers. I wish I could do it at home. Yeah. Get access to a virtual environment. Cisco Packet Tracer, Juniper VLabs, create an account, log in. Cisco DevNet Sandbox. There's a bunch of free access in the Cisco DevNet Sandbox area for all kinds of different Cisco platforms. Okay. Somebody said, where am I at? Not so much.
Someone said I barely dabbled in routing, mainly layer 2. Wireshark will also show lost packets.
Yeah, if you barely dabbled in routing, Rat Tech, if you could get a couple routers and just start to understand and appreciate that a router only can route packets for routes that it has in its table. And then you can start to learn, I got to either connect networks to the router and it learns about routes by virtue of the fact that they're connected, or if there's multiple routers, then you have to point a route to the next hop. Routing is a hop by hop proposition. It's a hop by hop deal. If a router doesn't know where to send a packet, connectivity is broken. So understanding routing is really understanding that each router has its own routing table, and that routing table in that one router will make or break the connectivity beyond that router. And how do all these routes learn, how do all these routers learn all these routes? Dynamic routing protocols. Or a person like you is creating static routes and you need your head checked if that's the way you're running your network. I mean, there's a case for static routing, but for any scale or any redundancy in a network, you won't be doing static routing. You'll be running dynamic routing protocols. All right. So yeah, try to get your hands on a couple routers, whether it's in a virtual environment or they're $25 cheap old Cisco routers. Who cares? You can learn a lot about routing from an old 2500. Okay. That's got 10 meg Ethernet AUI connections on it. Wireshark will show lost packets. Yeah. Excellent. Wireshark shows a lot. I just ordered the NetTool IO Pro. Can't wait. Excellent. Wireshark for getting IP address. Yeah. Nice. Agreed. Yo, Josh. Somebody knows you.
What's up? Wait, who is it?
I don't know. Either from videos or elsewhere.
Oh, possibly.
I just subbed to your YouTube. Excellent.
Nice.
Cool. I'll try to put out more videos in there.
Are you a network engineer? Yeah.
Yes, I'm a network engineer of 25 years in the IT field and really like 20 years of full network engineering for the U.S. Marine Corps, as a contractor for the Navy, a contractor for the Air Force, but I'm no longer with the DoD. I'm now with a commercial ISP, and it's been about 14 years working for an internet service provider, and I really like it. Thanks. I'll make sure to check them out. Cool. Policy-based routes. Yeah. PBR. Filter-based forwarding is Juniper's terminology for PBR. Interestingly. Yeah, you're bad. Oh, I'm sorry. Okay. So appreciate all the back and forth. Y'all are awesome.
Appreciate the love.
Yeah. Good questions. Good questions. Let me flip the camera. Here we go. And so let's get moving on this. Go back, and I think we were just digging in to some of the options. Show run interface fast F00 just to make sure that we're still sitting where we were a minute ago. Okay, basic HSRP standby command. We haven't done anything else. Now let's look at the brief output. Okay, we still need to learn a standby router. If you don't learn a standby router, you don't have redundancy in this network. Let me get back to my picture here. Okay, so let's get that going. I'm going to move you over to router 2, right?
Yeah.
Okay. You're on router 2 now.
Okay.
So I'll configure this one.
Now we are on router 2.
HSRP.
Yeah.
T, and then this is going to be on F00 as well too, right? For that.
Yes, same. Okay. F00.
And
what kind of firewalls am I familiar with? ASAs, starting to get more familiar with firepowers in the Cisco family, and I'm familiar with SRXs. I'm about to start getting, hopefully I'm going to get pretty serious about putting out some videos of me learning about SRXs in Juniper as I pursue a certification in Juniper, JNCIA Sec. And so I might try to share some good nuggets along the way as I go through my study track. Oh, dang, Cisco DNA will replace CLI. Yeah, there's a lot of newer ways of managing networks that lead us away from doing hop-by-hop CLI configurations. That's what automation is all about, is, you're not going to be, at scale to create, to be able to do a lot in a large network. That's where automation becomes really powerful. Do you like working at the ISP more, or what? Yeah, I like working at the ISP more. I like working in the service provider realm. As you'll see on my YouTube channel, I'm pretty heavy SP. How did you get started in my network engineering career? Slyfall asked that. Through the Marine Corps. I was in the infantry, and I made a lateral move in job fields. After 4 years, I re-enlisted for an additional 4-year contract, and the Marine Corps retrained me in IT. Okay, so let's get going. Standby. We're about to create the same. Now, did we change the IP address?
I was about to ask that.
Yeah, let's look. Just hit the up arrow. Watch this. Hit the up arrow. Control A. Control A.
Oh.
Do show run. Space. Enter. Okay.
No, we didn't.
Oh wait, that's F00. Oh, you put that on the wrong. You put that on the wrong interface. Say no IP. Just say no IP address. Enter. Enter. Yeah. Interface F. Hit the up arrow for do show run. Space. No. 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 F01. Yeah. What's that?
30.1.
That I thought you did a no IP helper on that.
Oh,
Okay. Type no IP helper on that. Did you go into that interface yet? You're not in that interface yet, are you?
Yeah.
Interface F01.
I am in it.
No IP helper. We're cleaning up old lab stuff. Enter.
Okay.
And then IP address 192.168.20.3. That's going to be this one, 20.3. Okay? Okay. Now here's... Now did we put... Yeah, go ahead and do that. 192.168.20.1. Yep.
Which is the virtual router.
Yep. Control Z. Show standby. Brief.
Oops.
Go ahead. No. Just keep typing. Who cares about the messages? Up arrow. BR. BR.
It's another boat.
No. BR.
Oh, shit.
Brief. It's just cleaner. It's little. So there is state as a nit. Interface is down. Hit the up arrow twice. And let's see if it still says state as a nit. Up arrow twice. Yeah. Interface is down. Show IP interface brief. Okay, so our interface is down to the LAN. It's port 0, F00. We're supposed to be connected into FO. Oh, look what's hanging around my neck.
The cord they're supposed to plug in.
The cord is hanging around my neck. So we're supposed to be plugged into FO23 on switch 1. And that's the top one?
Yeah.
What is
Top one is switch 1. Bottom one is switch 2.
FO23 connected to? FO23. FO23 is connected to FOO. What's wrong here? Why did you put that on FO1? Yeah, that needs to be on FOO.
Okay. Do I have to take it off F?
Yeah, you got to take it off. No IP address, that's it. Enter. Yep. And you probably have to put the standby command back in there, and it might need to be removed off the other one. He was on F01. What are you trying to set up? We're setting up redundancy in the first hop of a network.
Oh shoot!
Every network has a first hop that forgive the scribbles on here, but we have a laptop here. It's connected to a switch, and then this is the default gateway. Well, if the default gateway goes down, then the computer can no longer talk to the internet. So we've set up another router, and then these two routers will communicate with a first hop redundancy mechanism and decide which one is going to be the default gateway, so that if one of them goes down, the other one can take over, and we have what's known as first hop redundancy. Okay. So Control Z, show standby brief. What am I looking at, Josh?
You are showing the whole screen.
Standby brief. There we go.
Cool.
So we're on router 2. Router 2 is the standby router. The active router is 20.2. Standby is local, and that is the virtual IP. All right. Now, we need to, before we can test in redundancy off the LAN by bringing down one of these routers, go back and look at F01. We need to make sure F01 is linked up to the internet, so to speak. So go back, show run interface F01.
IP address.
Okay, put that IP back on there. 8.8.8.2, right?
Okay.
Keep up the good work. You bet.
8.8 you said. And then 255.0.
Yeah.
Okay. Got it back.
Just became top 1 viewer.
Heck yeah, congrats.
Awesome. No, that's a switch, LOL. Nah, it just loads of switches. Fans are noisy.
These are noisy.
Yeah, here, I'll give you a close-up on the noise.
Some Cisco switch
They're
ASMR.
not too bad, actually. Okay, Control Z.
Okay.
WR.
Saving config. Do you want to check the show IP interface? Brief. Okay. We got
Okay, yeah. So, let's do this. This router 2 is the standby router.
Mm-hmm.
Okay, and so we'll yank the cable on router 1, the top one. Oh, we haven't even connected. Shoot. Okay,
Yeah.
let's connect. We're gonna connect router 2 to the internet.
I'd like to see
F01. We'll connect it to port 23 of switch 2. Let's
You want to try and disconnect the active router and watch the standby
Yep.
get
Exactly.
elected as the new active?
Yes, I
Okay.
do. And so what we'll do is we'll look on the command line here. Here's show standby brief. And you'll actually see messages as well. Okay, I'm waiting for spanning tree to slow down or to converge and this port to go green.
This is the part where I fast forwarded in Packet Tracer. Fast forward time.
Okay, there we go.
Okay,
So we're gonna right here, we're gonna yank this cable on F00 of router 1, which is the active router, and we should see the standby router go to active. Okay?
Okay.
So
Motor GRG says, I wish I could see that from the beginning. We'll be posting the
let's post
fully
it.
recorded video on the YouTube channel. If you check out the
the
profile in the bio, there should be a YouTube link that you can click, and it should take you to the channel.
Okay, so preemption is disabled. That's something else, but there might be a timer in here that doesn't allow it to come up right away. I can't remember for sure, but let's see. Let's see what happens. We're just gonna do this. We're gonna bring down this router. We're gonna disconnect F00 on router 1. You ready?
Yeah.
Okay. Oh shoot! This cable came out.
Did it?
Which one?
The standby?
I don't even know which one that was. FO24. That's actually no. That's on switch 2. Okay, yeah. Let's wait for that to come back on. I'm gonna
Rat
wait.
Tech says you got a new sub on the YouTube.
Sweet.
Appreciate it.
So let's see what's going on here.
SNS says, don't you need preamp to negotiate? That's correct. And he's got a point. If it's disabled, are we going to have an issue with a new one getting
I
plugged
think
in?
preemption might be if you bring a new member of the HSRP group online, that it can take over of whoever the active router is. He might be onto something there. I have to read.
I think he's right.
I have to read into it. Okay, I'm going to yank port 24 on switch 1.
Okay.
And let's see what happens to my laptop.
You got the pings going still?
Okay, I just pulled it, and we're watching the console over here at the same time. My pings went down
Last timed out.
because my default gateway is down. Oh, look what just happened. We went from standby to active.
Okay.
Okay.
On R2, right? Yeah, this is R2 we're on. Now, shouldn't there not be much downtime whenever there's a default gateway that goes down and there's redundancy within another router that powers up?
Yes, there should not be much downtime, but I think what's going on is something's having a problem back here. I think there's a problem with the way this routes back.
Okay.
Okay. So,
because I did a couple simulations in Packet Tracer, and whenever I disconnected the ports or the cables like you just did, typically you don't see any disruptions in the pings at all.
I think it might have something to do with the way we configured this back here. And I don't think it has anything to do with HSRP, because we have an active router right now. You know, we have an active router. I think if we disconnect, I think port 23 is being used to route, port 24 is probably being used to route back to us. And I bet you if we disconnect it, let's see if the pings come back. Yeah, it might be the way we're trying to emulate the internet.
Yeah. Rat Tech says you should do a trace route to see the routes change.
Okay.
Let's try that.
Let's do that. Trace route. We're going to dot 3. So we first hop to the correct location. We're trace routing to dot 3. But when we ping 8888, so can we ping 8882? Yes. You know, I think it's got something to do with how we're emulating the internet, because I think HSRP is working okay. We can see that our trace route changed to 20.3.
Yeah. And
this brings up a really interesting point. I'd like to make a point to everyone is, you know, routing is a two-way proposition. Your routing can be good going out, but is it good coming back? And HSRP only controls redundancy on the way out. Okay? So getting redundancy, I could probably draw this again. You have a router here and a router here, and you have a LAN or a VLAN with computers hanging off of it. Well, HSRP on these two routers, router 1 and router 2, just decides who's going to be the first hop router for the computers to communicate outbound in that direction. All right? So we can see, just like somebody, you know, stated, why don't you just do a trace route? Well, we can see that the packets are getting to our standby router .3 now. You know?
Yeah.
But at this point, those packets, we don't know what's going on back here. That's a completely net. We'll just put a question mark. So yeah.
Someone says force it back with quad zeros. Or do a show run on both routers.
Force it back? Yeah, maybe that's what it is on switch 2. You want to go to... It's just a LAN though, so I'm not so sure. I think I think it would take more tuning, but anyway,
it's a good idea to reset these routers and switches to the default settings before starting too.
Yeah.
But
anyway, I think that's all we got for HSRP though.
Yeah, you're able to see it power on as active whenever you flip the take the port off.
We know that whenever we downed the other router, that this standby router did in fact come up as the standby, and we know that our trace route packets are going through that new first hop. So that was successful. But there's something else, some other challenge that needed to be solved back here on how the packets get back. Anyway, glad you guys tuned in.
You got a couple of questions.
And we can look at some questions here before we sign off. I could barely subnet correctly in networking essentials. This blows my mind. And you know what? Go to go to my bio, look at my YouTube link. I got a bunch of subnetting videos that will probably help you. Hey, Original Alarm, I'd really appreciate reaching out to me and helping me figure out how to stream from my desktop. No joke. I really am tired of like trying to make videos with this phone. Yeah. And so I need to know how to do that. How do I get this stream key? And somebody's giving us a new message.
Yeah. Well, it's just updating in the bottom.
Oh, okay.
He says
you have to apply. All right. You know, I don't know where to apply. I'm gonna dig in on YouTube. I saw somebody talking about it, but if you can help some way, reach out to me. That'd be great. I appreciate it. Thank you. I'm taking the Cisco class at UNLV soon. Awesome.
Nice.
Yeah, good stuff. You show Ron and see if there's any rogue config. Thanks, Rat Tech. Yeah, I mean we had previous lab configs in here, so something might be messing up the stuff coming back. So anyway, we did a basic HSRP config. I can get you some directions. Thanks, Original Alarm. I appreciate it. So what are we doing, Josh?
Well, I was just saying you can move it back.
Yeah. Okay. Well, hey, we're signing off, and hope to have some more. Hope to have some more TikTok lives in the future for you guys. All right. Take care. Bye bye.